Okay, the chain rule 2, that's part 2. My intention here is not to teach you the chain rule, but just to help you apply the chain rule to some problems here. So I'm going to give you the chain rule that says that the derivative of this composite function f of g of x is equal to f prime of g of x times g prime at x. And let's see what that might look like. So let's find the derivative, please. So find the derivative. Find the derivative. Could also say differentiate. Could also say find dy dx or ddx of f of x, etc. Here's our function. Our function today is going to be f of x is equal to, and then look, I'm going to just try to color code this a little bit so maybe we can see this. Let's have instead let's have 3x minus 2x squared, I think. Is that all right? And let's have this whole thing to the third power. And what I'm suggesting to you is this, is that there are two parts that comprise this function. The part in yellow is the outer part of the function, and I'm saying to you that's f of x. And inside of that there's a second function, and there's this parabolic thing happening in here, isn't there? And that the way that we find the derivative of this is through using this rule. So all I'm going to do here is same thing I always do, which is I'm a big list maker. So I'm going to make a list here of the parts that I'm going to need. And the parts I'm going to need, frankly, are these parts right here. So what I'm going to do, I'm just looking for these parts right here, and I'm going to start building my list of parts here. So that's what I'm going for here. So we know, well, let's do this. Let's let g of x equal u, and let u equal this 3x minus 2x squared, if you don't mind. Okay, hopefully you saw the chain rule 1 video, because if you did, this should really be making great sense to you, and if not, sorry, but maybe you should go back and look at it if this is not all hitting for you. So okay, from here I'm just going to find f of u. So f of u, what I'm asking is what's happening here. It should be f of u. What's happening here? Well, we have u, right, this thing, to the third power, and from here we can build f prime at x, can't we? Because we're just taking the first derivative of u cubed, which happens to be 3u to the second power, right? And the next thing that we're going to need a g of x. So we're going to go and we're going to say, okay, here's our g of x. And what is g of x? Going back here in green, there's our inside function. And our inside function happens to be 3x minus 2x squared. From there, we're going to need a g prime at x, so g prime at x. And all we're going to do to find our g prime of x is take the derivative of g of x, which happens to be 3 minus 4x. Isn't that right? Yeah. Okay? From here, look, I've said this a million times, and those of you who watch my videos, you got to be getting sick of this by now, but this is just fill in the blanks. Fitbo. The application of calculus is hard enough, so when we have things that are formulaic, we should probably stick to them the best that we can. So I'm just going to start filling in the blanks here, and it says here that we want f prime at g of x. Well, f prime is this right here, isn't it? So f prime is 3, and I'm going to put u in here, u squared. However, we want f prime, so this is f prime, but we want at g of x, and g of x happens to be this piece right here, right? Here's our g of x. So I'm going to take that piece and just place it in here, 3x minus 2x squared. All right? And then here's this multiplication sign right here is this one. So I'm just following the form here, and here. And it says times g prime at x, and g prime at x is, as we can see right here, is 3 minus 4x. Now, some of you are going to maybe expand this or whatever. It's not always necessary. I'm sorry that we brainwashed you so well in algebra and advanced algebra, but this is not necessary. Your professor will be more specific, but I would definitely take it in this form. So I'm going to leave this answer like this, and let's see if we can do another example, okay? So this is our f prime at x, right? This is f of x. This is f of x. Our f prime at x is this value here. So this is our function, and this is the derivative of the function, right? That's our derivative, okay? Okay, good. Let's try another one. Let's try to find, so let's Just saying it a different way. Let's differentiate. F of x is equal to, and this is just a way of looking at something, is the cube root of x squared minus 1 to the second power. And I know that you're like, wow, Charlie, why'd you have this second power? Why'd you make it pink instead of yellow like the other one? Because what I'm trying to convince you of is that this form right here is not a differentiable form for me. Well, it's not easily differentiated out of this form. So what I'm going to do is just make it a aesthetically pleasing, a prettier form, however you want to do that, but whatever. Isn't it true that I can just do this rewrite and rewrite this as that our function f of x is actually x squared minus 1, right? We can turn this radical into a rational exponent, and this can go with it. So this would be to the, right, so you can really see this, 2 something pretty. Sure, white. So to the 2/3 power. All right. Now maybe we can see this. I'm going to change all this color over to blue, I think. So that's where I got my 2/3 from, right? And now I'm asking you, now can you see the two different functions, one in blue and one in yellow? So what I'm going to do now is make my list. It's always that damn list, isn't it? F of x is equal, ooh, whoa, sorry you guys, I'm going to change this a little bit, right? I'm going to use a let statement. Let g of x equal u, and let u equal x squared minus 1, right? Then we're going to start taking this and say, well, what is f of u, right? Well, f of u happens to be u, which is this, u to the 2/3 power, doesn't it? To the 2/3 power. From there, we can definitely take f prime at u, and f prime at u is equal to, just multiply here, 2/3 u to the negative 1/3 power. Isn't that right? And then from there, we're just going to keep building. We look at that list from the last page of the pieces that we're going to need. We need a g of x, and our g of x is x squared minus 1, isn't it? We need the derivative of that. So g prime at x is the derivative of this piece, which happens to be 2x, doesn't it? Okay, hopefully you're starting to see how this is working. Now I'm just going to go back and build, right? Remember that our derivative is equal to f prime, well, let me do that again, is f prime at g of x times g prime at x, right? So all I have to do here is fill in the blanks, right? So I'm going to go back and fill in the blanks here. F prime at u is 2/3, right? To the negative 1/3 power of this, so x squared minus 1 times 2x. So believe it or not, we're kind of done. There's not a lot of work we can do here. We could certainly multiply this 2x. These are all factors. This is a factor, this is a factor, this is a factor. So we can take these factors out of order. So we can multiply 2x times 2/3 and get 4x thirds, can't we? And we can do this. We have a negative exponent here, so we can cure that negative exponent by doing this, x squared minus 1, right? And 1/3 power would be the third root, wouldn't it? So we could multiply that out and we could get 4x, right? Sorry, over 3 times the cubed root of x squared minus 1, couldn't we? And there's our derivative. So, all right. Let's take a look. I don't know where we are for time right now. Let me take a second to figure out where we are and see if we want to keep going or not. Yeah, good enough.